So good evening everybody. The Great Moon Hoax. This is a look at the evidence that's purported to be evidence that the moon landings didn't take place. So let's just get ourselves in the mood and remind ourselves what happened, how many years ago is it now? Nearly 52 years ago. Let's use that as the benchmark before we go and start to look at the evidence.
It's one small step for man, one giant leap. So, I guess you want to do it again. Okay. Sorry.
That's probably not the version you remember. You probably saw take 2 or take 3 or take 4 on the TV and you assumed that you were looking at the real video from the surface of the moon. But no, apparently the moon landings were hoaxed. We can tell that because there are thousands or hundreds of thousands of web pages that say so. There's also magazines, there's also books, there's also articles. And a lot of these various web pages and books, etc., say the moon landings didn't take place, and here's the evidence. And I thought that's interesting. If the evidence is based on images and videos, because of my interest in imaging, I wondered if we look at those images, can we actually tell if they were fake or if they were original? Can we actually prove that they are originally taken on the surface of the moon? Well, it's said that the actual moon landings were done on a soundstage, possibly in Hollywood, more likely Area 51. If you're going to be secretive about this, if it's going to be a conspiracy theory, let's do it somewhere secret. So presumably actors were put on soundstages in Area 51, and that's where you see all of the photographs, all of the videos, all of the TV footage, etc. came from there. So we can ask, how did it all start? Why would you think there might have been a hoax? Well, it started because Kennedy made a promise.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
Some key words there, impressive and important for sure, but also it's going to be difficult, it's going to be expensive. And perhaps Kennedy, or more likely his advisors who were telling him what to say, or telling him that we could do this, maybe they simply underestimated how difficult and how expensive it was going to be. And so it's said that the moon program got into difficulties in between Kennedy making the promise and the end of the decade. They got into difficulties and realized they couldn't actually keep President Kennedy's promise, and therefore they had to perpetrate the hoax. So it's not denied that this beastie did actually exist. The Saturn V has launched many times and lots of people have seen it, therefore it's difficult to say that never actually happened. So yes, Saturn V rockets did exist and did take men into space. So yes, this is a genuine picture of some of the Apollo hardware. You can see the Earth in the background. This was some testing done in Earth orbit, so that is not contested. But taking astronauts from the safety of Earth and sending them off to the moon, that is the point at which the hoax started. So in other words, that picture of a man in a white suit standing next to a very large Airfix model is not taken on the surface of the moon. That is what is said. That is simply on a sound stage somewhere. And again, that individual, I mean, you can see that that's not real. You can see that that's just grey sand that he's standing on. You can almost see that it's a cardboard background there. So again, you can clearly see that none of this is real. So what we're going to do is to look at the evidence. If people say the moon landings didn't take place, and here's the proof, here's the evidence, let's have a look at that evidence and ask ourselves, does it actually stand up? Does it stand up to scientific scrutiny? and we're going to look at a few pieces. We haven't got time in the, 3 or 4 hours I've been allocated this evening, something like that. During that time, we haven't got time to cover everything, so I'm just going to literally take a small piece, a few small pieces of the evidence and have a think about it. So it said that computers weren't up to the task of putting a lunar module on the moon to an accuracy of a few tens of meters. It said that radiation would kill the astronauts. And there's various video clips and various images that purport to be on the surface of the moon but can be shown to be fake based on the argument of the conspiracy theorists. So let's have a look at a few of those. Again, we haven't got time to do all of them. I'm just picking a couple of each. So yes, I can be accused of just cherry picking the evidence, but we simply don't have time to cover it all. So let's start with computers. Computers were too big, and the computing power available in the 1960s simply wasn't up to the task. So it is said many times that the computing power available surely wasn't even up to the capacity of a modern day mobile phone. Well, that's certainly true, but it's a vast understatement of the problem, because the computing power available was closer to, for instance, a musical Christmas card compared to the power in your mobile phone. So what did NASA do about this particular problem? They went to the best people they could think of. They went to the computing division of the Massachusetts Institute of Technology and said, cram a computer into a small box. You've got something like a cubic foot of space. It can weigh a few kilograms, but it mustn't occupy more than this space. Put everything you need in there to get us to the moon. And the question is, was that sufficient computing power to actually navigate to the moon? Yes, it's about a cubic foot in volume. As it happens, it's about the same form factor as a modern day PC, rather coincidentally. You can get an idea of the size from the keypad on the right. Bearing in mind it's a rather chunky keypad because it's designed to be used by astronauts even if they're wearing gloves. And anybody who says the computing power of the 1960s wasn't up to the job is not necessarily deprecating the amount of computing power available. They simply don't understand the job that the Apollo guidance computer had to do. Basically, it had to solve Newton's equations of motion. These are the equations that have been known about for 400 odd years. And when we take physics undergraduate students, in the first week of their first semester of their first year, we get them to solve these equations essentially by hand. What are the equations you need? Newton's laws of motion. If I want to go from where I am now, moving at this speed, and I want to be over there, moving at that speed, and I've got this sized rocket behind me, which direction do I have to point and how long do I have to burn the thrust on this particular rocket motor in order to get me from here to there? And if your computer can only do thousands of calculations per second, rather than probably if you're looking at this on an iPad or a laptop, your machine in front of you can probably do 1 billion calculations a second, not simply a few thousand. So your machine is 1 million times faster, but if the only job of this computer is to solve Newton's laws of motion for a particular problem, punch in the numbers, say how long do I have to burn the engine, and if it says you have to do a 20-second burn, then you put that in. Well, if that's all it has to do and it takes a second or two to come back with the answer, that's fine. It takes 3 days to get to the moon. If it takes a few seconds to solve a particular problem, it doesn't matter that it can't solve it in a microsecond. A few seconds is enough. So yes, the Apollo guidance computer was 1 million times slower than your laptop, but it didn't have to run Windows 10. It didn't have to have a graphical interface. It didn't have a QWERTY keyboard. It just ran the numbers required to get from A to B, to get from the Earth to the moon. And yes, it was up to the job. Excuse me. Bear in mind, this particular piece of evidence isn't a piece of evidence. Somebody says the Apollo guidance computer, or computing in the 1960s, wasn't up to the job. That is simply a statement. Arguably, it's somebody's opinion. It is not a piece of evidence. Their opinion is it wasn't up to the job. They're wrong. Let's have a look at another one that falls into the same category. Radiation would have killed the astronauts. Again, this is not strictly speaking evidence. This is simply a statement. So yes, there are radiation belts surrounding the Earth. The Sun emits charged particles, rather energetic. Protons and electrons are coming out of the Sun all the time. And the Earth's magnetic field, shown here as these dotted lines, that tends to trap these charged particles, and they end up in this sort of blue donut around the Earth, the so-called radiation belts, or the Van Allen radiation belts. So anybody who says astronauts travelling to the moon would have received a lethal dose of radiation is making a statement rather than providing a piece of evidence. And you can say, well, yes, these radiation belts surrounding the Earth, these donuts that we can see sliced into in this diagram, these radiation belts are indeed lethal, or at least they would be lethal if you stayed there. But the astronauts are not staying in the radiation belts, they are travelling through the radiation belts on the way to the moon. On this scale, the moon is probably a few meters away over to one side. And of course NASA know what the radiation threat is, and wherever possible they would not fly the astronauts directly through the Van Allen belts. They would try wherever possible, because of the tilt of the Earth, because of the tilt of the moon's orbit, they would try and arrange it so the astronauts were actually sent through, perhaps clipping the top or the bottom, the north or the south part of the belt, rather than going ploughing through the centre of the belt itself. But even if they did go through the belt, how long would it take them to traverse the belt itself? It's a 3-day journey to the moon, and they might, at 25,000 miles an hour, they might spend perhaps an hour or so in the Van Allen belts. So yes, they will pick up a radiation dose. And I'm sure the astronauts were told that as well. They were probably told before they went, yes, you guys are going to fly through the Van Allen radiation belts. We've known about these since the 1950s. We know they're there. You are going to pick up a radiation dose, perhaps equivalent to a chest x-ray. Nobody would volunteer for a chest x-ray if they didn't need one, but unfortunately this is a necessary hazard. So yes, you're going to pick up the radiation dose of a chest x-ray, and there's always the possibility that later in life you could find that you have an increased risk of getting cancer. That is one of the hazards that the astronauts knew about. It wasn't necessarily number one on their list of things to worry about. Remember, they're being told as well as that, by the way guys, we're going to stick you on top of a rocket which is made up of about 3,000 tons of highly volatile rocket fuel. And yes, the rocket was built by the firms that put in the lowest bid. Okay, just remember that, guys. That is more likely to be number one on the list rather than a radiation hazard which is down there at number 17 or number 18. So again, radiation would kill their astronauts. That's a misunderstanding of the Van Allen belts and how long the astronauts spent in that region of space. Again, not a piece of evidence, a claim. And they're wrong. Okay, let's have a look at genuine pieces of evidence. Let's have a look at some videos and some images and see what people say about them in terms of them being fake or recorded on Earth. Let's start with some videos.
Maybe it'll, that sort of looks like it's waving in a breeze.
How many times can a man turn his head and pretend that he just doesn't see? The answer, my friend, is blowing in the wind. The answer is blowing in the wind. Yes, and how many deaths will it take till he knows that too many people have died? The answer, my friend, is blowing in the wind. The answer is blowing in the wind.
A number of clips there of flags blowing in the wind. Presumably this was a soundstage and somebody left the door open and the wind came through and made the flags flutter. But of course there's another explanation. I once asked this to a hall full of school children, what do all of these clips have in common? And some precocious young individual put his hand up and said, they're all the American flag, which is true. Yes, none of them are the Union flag for reasons I haven't quite fathomed out. But yes, they are all the American flag. But the other thing all of these clips have in common is that there's always an astronaut hanging onto the flag or trying to plant the flag or trying to unfurl the flag. And as it's moved backwards and forwards, there's a tendency for it to flop backwards and forwards and give the impression that it's fluttering in the breeze. But whenever the astronauts have let go at the flag, it might then bounce around for a little while thereafter. But generally speaking, whenever you look at the flag in any images from either TV cameras or from cine cameras, once the astronauts have left it alone for more than a few seconds, and as long as it's not too close to the lunar module where it could be affected by air venting or other things from the lunar module, then the flags stay absolutely dead steady. So there's no sign of flags blowing in the wind, there's only signs of flags moving under the influence, usually, of an astronaut manhandling it. Let's have a look at another piece of video which is oft quoted as, "This can't be real." When Apollo 17 took off from the moon, why is there no plume of exhaust from the engine?
99, proceeded, 3, 2, 1, ignition.
A flash of light, but then no big rocket exhaust coming out of the back. After a few seconds, when we're looking up at it, we start to see a little glint of light. There it is. We're now looking into the engine. But on its way, there was no sign of a large flame coming out of the back end of the rocket. If there's no exhaust plume, clearly it must be a studio model. It must have been on wires and it was simply yanked up on cue such that the camera could then pan up and watch this little model ascent module going up into the sky. Well, that's possibly what you would expect. You look at this and you think, well, would there be an exhaust flame? Well, there's a tendency to think that any rocket produces a plume, an exhaust plume, which is clearly visible. Because let's face it, when we think of Apollo, that's what we think about. That is a proper rocket. That is, look at that. White hot tongue of flame coming out of the back end of the first stage of a Saturn V. Why does that look so different from what we've just seen? Is it because that is real and the previous one was just a model in a studio? Or is there a different explanation as to why the rocket plume looks completely different here? Some people think maybe it's to do with the fact that this is in Earth's atmosphere and that was in a vacuum. No, it's all about the fuel. What's being burnt here in the first stage of a Saturn V? It's kerosene. It's effectively a sort of aviation fuel. It's a hydrocarbon. And once it's been burnt in those huge F1 engines, what comes out of the back is those hydrocarbons at very high temperature. They are literally white hot molecules in that particular plume there, and that's why it appears white hot. If you were to take a different fuel, for instance, if you were to take hydrogen and oxygen and burn those, the byproduct that comes out of the back of the engine would be water vapour, which is essentially transparent. And that's what the shuttle engines are burning, and hence the exhaust from the shuttle engines is virtually transparent in contrast to what we see from the Saturn V. Hang on, you might say, there's no way you can claim that the shuttle's exhaust is transparent. Just look at that. If anything, it appears to be even brighter than the Saturn V. Well, let's look a little more closely. No, what we're looking at is the exhaust there from the solid rocket boosters on the side of the space shuttle. So these, again, are burning solid fuel and we're getting some white hot exhaust there. But the shuttle orbiter itself is burning hydrogen and oxygen from this orangey tank that I'm pointing to here. So the hydrogen and oxygen are being fed into the orbiter, into its 3 engines, which are going full tilt, and those 3 engines are producing a huge exhaust plume, which you basically cannot see, because the byproduct of hydrogen plus oxygen is water, and that is virtually transparent. If you look closely, perhaps you can see some shock waves in the almost invisible exhaust plume, so you get these little shock diamonds occasionally visible, but compared to the white hot plume that we see from the solid rocket boosters, the exhaust from certain fuels is almost invisible. Now, the ascent module doesn't actually use hydrogen and oxygen, but the point I'm trying to make is just because you expect to see a huge tongue of flame coming out of the back of a rocket motor, just because you don't see it does not mean it's fake. It might depend simply on the fuels that are being used to make the thrust in that particular engine. Let's have a look at some images, and this is sort of what got me started, because I've got an interest in images and image processing and image analysis. I was interested in people who said, look, here's a image that is purportedly taken on the surface of the moon, but we can point out the problems. These shadows are impossible, it is said. There's supposed to be only one source of light on the surface of the moon, the sun, and the sun is a long way away. We're looking at perhaps a few hundred meters here, so to all intents and purposes the sun is an infinite distance away, certainly compared to a scale of tens or hundreds of meters. And if there's only one source of light, all the shadows produced by any objects in the field of view we're looking at, all of those shadows should be parallel. Or perhaps like the perspective effect you see when you're looking at railway tracks or motorway lanes, they're parallel, and they either should look parallel or perhaps they'll appear to converge to a point on the horizon corresponding to where the sun is positioned. But it is said that you should never get this particular situation. Let's have a look at some of those shadows. There's a shadow of the lunar module. We can't see the shadow from the person that's standing there, but we can clearly see the shadow from the lunar module there. So if we just draw a red line through it, that means the sun must be coming from that direction as indicated by the red line. But if we look in the foreground at the shadow of the rock, we see that that would imply that if there's only one source of illumination producing the lunar module shadow and the rock shadow, then the source of the illumination must be there, which makes no sense whatsoever. Not only that, but if we had chosen a different rock, we wouldn't even have tracked the shadows back to indicate a source in the same place. How can there be multiple sources of light producing all of these weird shadow angles? Well, clearly it's not on the surface of the moon. If the surface of the moon should only have the sun, and no, we're not talking about the Earth casting shadows here. Yes, the Earth is in the sky, but it will be not producing anything like the black shadows that we see here. The Earth will be many, many times fainter than the sun. Just like on Earth, the sun is perhaps 1,000,000 times brighter than the moon. You may think the full moon looks quite bright, but that's only because we see it on a dark sky, and we can never see a full moon next to the sun, of course, but the sun would be something like 1,000,000 times brighter than a full moon. And from the moon, the sun would be perhaps not 1,000,000, but certainly a very large fraction, maybe 100,000 times brighter than the Earth, and therefore the Earth will not be casting its own set of shadows. So if you say there's only one source of illumination, and clearly that photograph rules out that possibility, then that cannot have been taken on the surface of the moon. That is quite definitely a fake. These shadows are impossible. Well, that's one way of thinking of it, but one of the rules of a scientist is to think about Occam's razor. Do we have more than one explanation for any particular situation? In this case, do we have more than one explanation for these shadows? And Occam's razor says if you've got more than one explanation, then, if you'll forgive the paraphrasing, the simplest one is more likely to be right than the rather complicated one. If you've got an explanation that doesn't require a huge number of assumptions, and you've got another explanation that requires a huge edifice of assumptions, then the simplest one is probably the right one. It's not a universal rule, but it's a very good rule of thumb. The way to explain these shadows, other than saying this is Area 51, I think was demonstrated rather nicely by somebody, rather than trying to come up with a possible explanation or a mathematical model. He simply tried to reproduce, can you actually obtain shadows like that using a distant light source? And he made a little model on his kitchen table. He took a light source a long way away, and he illuminated this airfix model of the lunar module, which produces a shadow going off to the right, just as we see in the main picture. And there's a felt marker pen standing upright here, simply to demonstrate that its shadow also goes off to the right, which tells you that the source is a long way off to the left. If it was very close, those shadows would be diverging. They're almost parallel, telling you that the light source is a long way over to the left. But look what's happening here. He has put some little model rocks on top of a little plasticine mound. And what happens to the shadows when they fall not on flat ground, but when they fall on a slight slope? Well, those shadows end up going off at angles, which I hope you agree are very similar to the shadows in the image that we see in the right here. So in other words, one explanation as to why those shadows look the way they do is that the moon's surface is not perfectly flat. There are a few lumps and bumps. There's a little mound here and a little bump there, and perhaps these rocks are simply sitting on a little bit of a mound. You can't really tell because it's a two-dimensional picture. We haven't got a three-dimensional topography. But the question is that a simpler explanation than this is a fake and it was taken in Area 51 because there was a conspiracy theory which says the moon landings never took place? You have that explanation, and alternatively you can have the moon's surface is not perfectly flat. That's a simpler explanation, and that's the simplest way of explaining those shadows. You don't have to invoke a conspiracy theory to explain those shadows. So no, they are not impossible shadows. I showed this one earlier very briefly, and again this one has been shown many times on many web pages with the caption, "Why are there no stars in the sky?" And then perhaps underneath they explain, well, on the surface of the moon there would be no atmospheres, so surely the stars would be much, much brighter than we would possibly see from Earth, and they are not to be seen anywhere. So why are there no stars in the sky? Well, that's wrong for a number of different reasons. Correct, there's no atmosphere on the moon, but the assumption that because there's no atmosphere on the moon, that means the stars would be brighter, that is wrong in the first place. If you take the Earth's atmosphere and remove it from the Earth, apart from us all suffocating, what would that mean? Well, it wouldn't mean the stars get much brighter. Yes, indeed, the scintillation, the turbulence of the Earth's atmosphere causes us seeing problems, and it makes it difficult to get very high resolution, but in terms of how bright things appear, the Earth's atmosphere is almost transparent. Water vapour does absorb a little, and of course clouds get in the way from time to time, but if you ignore the clouds, water vapour doesn't absorb that much of the light coming down on the surface of the Earth. So on the moon we wouldn't expect the stars to be significantly brighter. Yes, they would be a little bit brighter, but not by a factor of 10 or 100 as some people seem to indicate. So if the stars are about as bright as you would expect from Earth, you can still come back and say, well, why don't they appear in this image? But anybody who's ever done any photography will know that if you're taking a sunlit scene, and remember on the surface of the moon that's a sunlit scene, you've got a man in a white suit and a relatively reflective object behind him, what exposure would you need if you were taking a picture of that in direct sunlight? Well, depending on the lens aperture, depending on the film you were using, you might expose that film for perhaps 1/1000th of a second. That's just a guess, give or take a little bit. And anybody who's ever tried any astrophotography, taking a picture like that behind me, for instance, will know that if you want to take a nice picture of the stars, you would open up the lens and you would expose for as long as possible. With photographic film, you would expose for even longer than you would for modern digital cameras. You might expose for many minutes or many hours to get a nice picture of the stars. So if you're actually exposing for 1/1000th of a second, that is too short by many, many, many orders of magnitude to expect to see any stars. If the Earth was in the sky, yes, you would expect to capture that, but no, you wouldn't expect to see any stars. But if you turn this around and say, well, I'm perfectly happy that there were no stars in the sky, if that's taken on the surface of the moon, you can turn it around and say, well, if this was taken in Area 51, and this was an actor in front of a model of the lunar module, and it's taken in a soundstage, Why didn't NASA paint some stars in the background just to stop people saying, ah, it looks fake because there were no stars visible? Why didn't NASA paint some in rather than have a pure black backdrop there? Well, say the moon hoax believers, NASA didn't paint the stars in the background because they didn't want to get it wrong. They didn't want to get the positions of the stars in the wrong place. In other words, they didn't want to put some stars in there and then have a load of people in astronomical societies come along 50 years later and say, hang on a second, Arcturus shouldn't be over there, it should be over there. So, well, you can believe that if you wish. If you don't believe that NASA know where the stars ought to be, then you have a very low opinion of NASA from the outset, it must be said. So again, there were no stars for very good reason. Another one that crops up quite a lot. Why did the astronauts leave footprints, as indicated by this image, with loads of footprints everywhere, but the leg of the lunar lander on the right-hand side here didn't seem to sink into the soil? You can do a quick calculation and say, well, how much pressure is there underneath an astronaut's boot? He's got a 100-kilogram backpack on and he weighs, I don't know, 85 kilograms or something, and you work out the area of his boot. You can work out the pressure and how much you would expect the boot to compress the soil. And roughly speaking, it's the similar pressure underneath a landing pad. It's about a metre or so in diameter. The lunar module would be 15 tons or so, maybe a little bit less because it's used some fuel to get down there. Yes, we're in 1/6 gravity, but that applies equally to the astronaut and the lunar module, so that doesn't come into the argument. So you can ask, well, if people believe this is fake because the astronaut's boot does sink into the soil, but the lunar lander leg doesn't, then you can look at that and say, well, okay, that's an argument. But again, if you want to answer the question directly, why did the landing pads not sink into the soil? The simplest answer is actually, they did. But actually you don't see it there. That particular image, that particular landing leg, does not appear to have sunk into the soil by much. Whereas a different image, I don't even know if it's the same mission offhand, a different image of a different leg, and that quite definitely has sunk into the soil by quite a few centimetres. So this is one example of somebody presenting an image and saying, look, there is something wrong with this image. Astronauts have sunk into the soil with their footprints, sorry, not soil, regolith, whereas the landing pad there doesn't appear to have been so, and that is suspicious, and because of that one image, I say that all of the images are fake, all of the missions were fake, the entire Apollo program was a fake. And anybody who makes that argument is simply choosing not to show you that image. They're showing you the image that backs up their hypothesis that the moon landings were faked, and indeed that is a perfectly reasonable bit of evidence that something looks odd there, but they're choosing not to present you with the counter-argument that, well, actually, yes, they do sometimes sink into the soil. It's the same argument with why did the engine not make a crater. Sometimes it did, sometimes you don't see it in images. If you choose to only show people the image that backs up your hypothesis, not the images that don't, then you are cherry-picking to the point where you are not applying the scientific method. Yes, I admit I'm doing the same in that I do not have time to show you every Apollo image to make my point. I'm simply saying that that's the sort of thing that you have to watch out for. Sometimes they only show you part of the story, and if you go to the NASA archives and look up all of the images, then you can often find counterexamples to what the conspiracy people are claiming. What about the cameras themselves? The Swedish manufacturer Hasselblad, NASA went to this particular camera manufacturer who make extremely good large format film and said, can you make us versions that will strap on to the chest plate of an astronaut? There you see it from Apollo 12. Let me just make that bigger so you can see it more clearly. There's a camera that's a modified version of the Earth version, as it were. It doesn't have a viewfinder on the top. And therefore people have asked, well, how on earth did the astronauts get the framing so beautifully right every time when they couldn't actually tell what their camera was looking at? It's strapped to their chest. There's no viewfinder, mainly because there's no point in having a viewfinder because of the constriction of the suit and the visor of the helmet. The astronaut couldn't really look down at what he was doing anyway. He'd have to work with a mirror on one of his arms or something like that. So Hasselblad have tried to make it as easy as possible. They've put paddles onto the lens here, which makes it a little easier because with gloved hands, of course, it's very difficult to grip something and turn. So they've made it as easy as possible to set the manual controls. Remember, there's no automation here. The astronauts had to set the shutter speed, the astronauts set the lens aperture, and the astronauts set the focus, all manually. And this was done with some practice. Yes, the astronauts were given the cameras beforehand and told to practice, go take a picture of your dog for a few months before using it on the moon, just so you're used to using this camera without a viewfinder. But one of the reasons I'm showing you this, we'll come back to the framing in just a second, one of the reasons I'm showing you this picture is because of these fiducial marks, these large black X's, which you can see on all images. They're just a little bit bigger here because I've blown up this little crop. One of the reasons those X's, those crosses are, are there is precisely that reason. So you can see that this is not the whole image because you can simply count the crosses and say, well, there should be a certain number of crosses. So if I can only see this many, then I'm only looking at a part of the image. And indeed, the cross that is the biggest cross, which we can't see here at the moment, is actually in the center of the image, so it tells you something about the field of view that you're looking at if you want to measure distances between crosses, and it also tells you if you're looking at a crop of the original image. But these crosses, I'm telling you this because these crosses are a source of problems for some conspiracy theorists. We come back to, again, an impossible image, it is said. Because these black crosses that you can see here, the largest one you may or may not be able to make out is down here. That tells me immediately that that's the center of the image. So this is a crop, not of the entire image. I've taken away the bottom of the image and just left you with the top because that's the interesting bit, the lunar rover. But these black crosses are made in the camera. You can imagine the light from the sun has bounced off the astronaut and the lunar rover, is gone through the lens of the camera. Before it hits the film, it goes through a piece of glass onto which are etched these black crosses. So the black crosses are in the camera. Therefore, this cannot happen. If we blow that up so you can see what I'm talking about, if the black crosses are in the camera, they can't be behind something that's in the field of view, the lunar rover. You can turn this around and say, well, if it is a fake, why did NASA not get that right? Why didn't they just draw the crosses in? Why would they bother drawing black crosses on all of these things? Well, who knows, but let's assume they've got it wrong here. So this is often quoted again as an impossible image because the black cross cannot be behind the white antenna. In this case, it's the antenna of a lunar rover. This is one image when I first looked at this and read the caption, "This can't happen." This is one image where I looked at it and thought, yeah, you're right, that shouldn't happen. Black crosses can't appear to be behind objects in the field of view. And this one, I genuinely had to stop and think and try and work out what was going on. With most other images that I've seen that are purporting to be fake images, a little bit of common sense tells you what's going on. This one, common sense couldn't get me to the answer of what's actually happening. And again, kudos to the person who not only explained it, but demonstrated how it can happen. And to me, a demonstration of how you can reproduce this effect is far more powerful than simply coming up with a theory as to why it might happen. What somebody did was go into their back garden and take a picture of a greyish card and a whitish card with a washing line in front of them. And I hope you can see that washing line where I'm now tracing the cursor. That washing line goes in front of both of those two pieces of card. It is quite clearly visible in front of the grey card, but what happens when a relatively narrow black object goes in front of a saturated, overexposed bit of white? Perhaps you can see it, I can just see it, perhaps it's gone invisible to you. It is very difficult to see a dark object if it's in front of an overexposed, saturated white object. That's a function of photographic film. It actually is also a function of CCD cameras. In photographic film, we're talking about exposing and changing the chemistry of silver halide crystals, and they can bleed into each other. In other words, when all of these silver halide crystals in this white area are completely overexposed, the chemistry can bleed over and actually form some of these dark areas here to appear white. And in the case of CCD cameras, electrons are filling up each of the pixels in an image, and if the electrons fill up the pixels all to the top, they can cascade over an avalanche into neighbouring pixels, and white pixels can make neighbouring black pixels appear as if they are white. In other words, that is a continuous black line there in the camera, but the overexposed white area here is just bleeding in to the point where our eye gets fooled into thinking that the black is actually behind the white, just as in this particular demonstration in the back garden here. And there are half a dozen, I think, different instances where a black cross appears to hide behind an object in the field of view. And if it does hide behind an object, that object is a saturated, overexposed white object. Black crosses don't hide behind grey objects, light grey objects, dark grey objects. If they're going to hide, they will appear to hide behind a saturated white object. So by no means obvious, it's not one that you can answer immediately with common sense. It takes a little bit of knowledge as to how photographic film works and how CCD cameras work, and it takes a very nice example from somebody who set up the same thing in their back garden to convince us, no, this is not an impossible image. It just takes a little more explanation than a simple 10-second response to, I can see why that's right. Returning to this idea that they don't have a frame, they don't have a viewfinder, so how on earth did everybody get such perfectly well-framed images? Let me answer that by coming back to an image you've already seen. On the left-hand side there's an image of Aldrin that I've already shown you in the context of footprints. And on the right there's the image we've just seen. Now clearly, one has been cropped to a rectangle, and I've removed part of the image, and they're different sizes, and I've done that deliberately simply to keep Aldrin roughly the same size in those two images. They were taken, I think, a couple of minutes apart or so. Clearly Aldrin has moved slightly. He's moved perhaps half a metre to his left. He's turned to face Armstrong with the camera. And he's moved his left arm, I guess, a little bit. But there's one key difference between those two images that tells you one of those images has got a problem. There is a problem with one of those two images, and I'll just give you a few seconds. I'm not going to ask for a show of hands, but just have a think as to what is the key difference between those images that tells you something is wrong here. Well done if you've spotted that in the left-hand image, Aldrin quite clearly has a backpack with a radio aerial sticking up. And on the right-hand image, Aldrin has a backpack with no radio antenna whatsoever. It's a radio antenna which is effectively covered in white material, and it's visible from all angles, and it's sunlit. In this particular case, the sun is coming from behind, but still it would be sunlit, and so should be clearly visible in both images. Clearly visible in one, for some reason not clearly visible in the other. The radio antenna must be there. It can't possibly have been folded down or broken off. If they had lost radio communication by some accident, they would have aborted the EVA, the moonwalk, and they would have had to decide what to do next. So that antenna must be there, and yet it doesn't show up in that image. A second clue we get that there's something wrong with this is looking at those fiducial marks. Again, I'm not sure how well this shows up on whatever you're looking at, but the largest of those fiducial marks, there are a few small ones dotted over the entire image, but the largest one, that's about twice as big as all the others, is there. The largest one should be in the centre of the image. But that red circle, I think you would agree, is not in the centre of the image. And that is the second clue that tells us something is wrong with that image. And it wasn't until I started researching this talk and looking at some of the images that are around everywhere that I realised, despite the fact that I've been looking at that image for, well, I guess since about 1969, I am familiar with that image in that I've seen it many, 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 many times in the last 50 years, and perhaps you have as well. But until I started looking at these images, I didn't realise that that is not the image of Aldrin taken by Armstrong on the surface of the moon during Apollo 11. I didn't realise that, and only when I started looking at these clues, the aerial, that cross, did I realise what had happened. That is not the picture Armstrong took. The picture Armstrong took is that one. He got the framing wrong. So in answer to the question, how do they always get the framing so good? The answer is they don't. And in this particular case, Armstrong was looking too low and he chopped Aldrin's aerial off. Sounds painful, but actually it was okay. NASA looked at that image and said, fantastic, that's the poster boy of Apollo. That's the picture that we want to go around the world a zillion times. We want that on the front of Time magazine. Oh, it's a shame he cut the top of his backpack off. Let's look at the previous one and the next one. The previous one is the one we just saw, not the same image. And the next one, Armstrong didn't take a second picture of that. He went away and took a picture of something else, some regolith or a piece of equipment or the lunar module or the landscape or something else. So that is the only picture of Aldrin in that pose. NASA liked it so much they said that is fantastic, but there's too much foreground and he's chopped his aerial off, so we are going to reframe it. We are going to move Aldrin down and stick a black rectangle across the top. Somebody might then have said, well, do we have to paint the stars back in? No, you don't, because there are no stars visible in these photos, so you don't have to worry about getting the star field right. Fantastic. But I'm sure there was a committee meeting at some point where the question was asked, having decided that's the picture we want, should we paint the aerial back in again? We would have to take that and we'd have to print it, then we'd have to get an artist to paint the aerial back in, and then we'd photograph the result again. No Photoshop in 1969, it would have to be done by printing and rephotography. At the time they decided, no, we're going to stick a black rectangle across the top, we are not going to attempt to put the aerial back in. After all, who's going to notice? Again, it's not as if 50 years later an astronomical society is going to come along and say, hang on, there's something wrong with that photo. So that is a genuine instance where NASA have doctored the image. The original in the NASA archives is there and it's not very aesthetically pleasing. The one that tends to end up on book covers and magazine covers and scattered around the internet tends to be that one with the black stripe across the top, because it simply looks nicer, and NASA admitted that's why they doctored that photo. They don't admit to doctoring any others, but that one they have owned up to. So I've shown you some pieces of evidence and some claims and shot them all down in flames. But the question still remains, if you turn it around, is there any evidence you can provide to somebody who believes in a conspiracy theory that proves beyond any reasonable doubt that the moon landings did take place? Well, that depends on your definition of reasonable, because if there's reasonable doubt, that implies that you're talking to somebody and you're making a reasoned argument. You're saying, here's the evidence that it did take place, here's the evidence that it didn't take place, and if we weigh up that evidence, we come to a conclusion. That's what a reasonable person would do. But I have found it's very difficult to argue with people who believe in conspiracy theories not only moon landings, but flat Earth and JFK assassination and, well, pick your conspiracy theory, basically. But if somebody believes in a conspiracy theory, they will believe all the evidence that backs them up, and any evidence that doesn't back them up, they'll say, either they'll pretend the evidence doesn't exist, or they'll find some way of twisting it and saying, well, you would say that, wouldn't you? So it's very difficult to prove beyond reasonable doubt that the moon landings did take place. What about this?
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? That proves that Mr. Galileo was correct in his findings.
Hammer and feather hit the ground at the same time. Try that on Earth. The hammer would arrive first and the feather would take a little bit longer to hit the ground. So is that proof that it was done on the surface of the moon? Well, no, for quite a number of reasons. One is we only have his word for it that it's a hammer and a feather. How do we know it isn't a plastic hammer? How do we know it isn't a feather that's made of lead and painted white to make it look like a falcon feather? He works for NASA. Of course he's in on the conspiracy, so we can't believe anything he says. And even if we believe that video, there are slightly higher resolution versions of that, even if we believe that, you could say, well, all you need is to put an actor into a huge vacuum tank and pump all the air out, and then you do the experiment and the hammer and feather will hit the ground at the same time. Well, yeah, I suppose so. It would need to be a rather technological feat to actually make a vacuum tank that big and do that experiment, but yes, you could argue that. The closest thing I've found to proof is this video. I forget which Apollo it is now. It might be 7. No, it's 16, I think. In which you see an astronaut. This is a clip from a much longer video where you see an astronaut driving a lunar rover. And the reason that that appears to be taken on the surface of the moon is because if you were to go through frame by frame and look at the dust kicked up by the wheels of the rover, they don't billow in the same way that they would in the Earth's atmosphere. If you do it frame by frame and look at the various particles that you can see, each particle kicked up by the wheels follows its own parabola as it goes into the air and then lands again. And it's not simply the fact of how long it takes giving you 1/6 of Earth's gravity, because you can always make the video run faster or slower. It's the fact that every particle goes through a parabola indicating that this was filmed in a vacuum. So you can say, well, okay, again, couldn't you fake that? Well, it's part of a run in which this rover travels over many hundreds of meters. And so this particular sound stage, which would all have to be in vacuum in order to have a continuous run of the video, you'd have to have a sound stage in which you had a vacuum tank hundreds of meters long and many, or probably tens of meters deep and maybe 10 or more meters high. And you'd have to evacuate that, and then you would run the video, and then you'd get a video like that. Could that be done? Well, it's not impossible. But I would say that the technological challenges of evacuating a volume that large in the 1960s and then running that video and getting that video inside a large vacuum tank, not impossible, but technologically I would say that is actually more difficult than putting a man on the moon. And therefore, why would you possibly fake that by building a vacuum tank and then generating that video? It would be easier to send a person to the moon and film it there. So, not 100% proof, scientists can never produce that, but that is, I believe, as close as you'll get. Some people talk about the reflectors that are on the moon, and lasers are being bounced from telescopes on Earth, bounced off these reflectors, and if you time how long it takes the light to leave the telescope, bounce off the moon and come back again, because we know the speed of light so accurately, we know the distance to the moon, to an accuracy of, I don't know, a few centimetres or so. And because there are a few sites with these reflectors, not only do we know the distance from the Earth to the Moon, we know what the Moon is doing in terms of tilting and nodding and librating and moving backwards and forwards. We get a very good idea of what gravity is doing, the interaction between the Earth and the Moon, by looking not only at the distance, but how one is affecting the other. That is not proof that we've been to the Moon, we as in mankind. That's only proof, if you want to think of that there are reflectors sitting on the Moon. Maybe they were put there by robots, or maybe a satellite has gone to the Moon and dropped these reflectors in place. It's not proof that a man has actually placed that in position. It's often been said, why doesn't NASA just kill the controversy stone dead and point the Hubble Space Telescope at the landing site and photograph the footprints and the flag and everything else, and then the controversy is dead? Well, there's a good reason for that, and it's not because NASA has never done that, not because it's scared to, which is what the conspiracy theorists would tell you. They've done so because, like it or not, everybody has to obey the laws of physics. Whether you believe the moon landings took place or whether you don't believe they took place, everybody has to obey the laws of physics. If you don't like equations, look away now. The resolution of the Hubble Space Telescope is the wavelength of light divided by its mirror diameter, which is about 2.4 meters. So the resolution of the Hubble Space Telescope is about 0.2 microradians, or 10 millionths of a degree, if you prefer. For astronomers who prefer arc seconds, it's about 0.05 arc seconds. Superb as a telescope, but when you calculate what would you need to see an object a few meters across, let's say the lunar lander is 4 meters across for the sake of argument, at a distance from the Earth to the Moon of 400,000 kilometers, you would actually need a resolution to make out the lunar module of about 0.01 microradians, or 0.002 arc seconds. In other words, the lunar module is too small by a factor of about 30. Or, if you prefer, the Hubble Space Telescope mirror would need to be 30 times bigger to have the resolution to be able to see the lunar lander as one pixel. We're not talking about the flag, we're not talking about the footprints. Just to make out the lunar lander as one pixel would need a telescope about 100 meters or so in diameter. That's why there is no point in pointing the Hubble at the moon landing sites, because it can never show what the conspiracy theorists would hope for, in the sense that it would never prove that they're not there. It simply does not have the resolution. I showed this image a while ago. Let me just make it bigger. This is Apollo 12, and yes, there's a little bit of a flare here. It's lenses of the time did unfortunately produce a little bit of lens flare, so the sun is over the astronaut's right shoulder and it's producing these lines and this blob, and you probably see this sort of pentagon here. That's a ghost of the shape of the aperture in the lens. So I've modified the contrast and brightness slightly, which is then made this not too bright, and in doing so I think I probably got rid of the aerial on the back of his backpack as well. But apart from that, there is something very wrong with this image. Again, I'll give you a few seconds to have a look at it and see if you can tell what's wrong with this image. Okay, time's up. When I've asked other people, some have started talking about the amount of light arriving on his right side compared to the amount of light arriving on his left side. But the real problem is simply thinking about how Apollo missions worked. Remember, 3 astronauts, 1 stays in the command module, 2 are on the surface. Here's an astronaut, and here's the astronaut taking his picture reflected in the visor. So who is this joker over on the left? How can you have 2 people reflected in the visor and the astronaut himself? That would imply 3 people on the surface. This image must be a fake. And for once, and only this once, I agree that this image has been faked by somebody other than NASA. And that's because I faked it. I went to the NASA archives and I got the image, and the image is this one. This is the image on the NASA archive. I thought, oh, look at that, there's a little bit of space there on the left-hand side. I went to a different Apollo mission, found an image of a different astronaut. He was facing the wrong way and his shadow wasn't right, so I flipped him over, changed his size, changed his contrast, changed his brightness, and plonked him on the left-hand side, and then just tidied up the horizon behind him. In a piece of graphic software, it takes 2 or 3 or 4 minutes to fake an image reasonably convincingly. I hope you agree that he looks about right, he looks about the right height, his shadow looks about right, but he simply shouldn't be there. That's NASA's version, that's my version. NASA, me. NASA, me. It is so easy to fake images with modern technology. Would have been tricky in 1969, but with the technology we have, with computers capable of billions of calculations a second, with the graphic software, Photoshop, other packages are available, or anything else, it is so easy to fake that you cannot believe anything you see, whether it be a static image or whether it be a video. You're probably aware of that, having been to the cinema and seen images of spacecraft or images of dinosaurs or images of who knows what. You know it's fake, but you cannot tell by looking at it that it is computer generated imagery. You can't tell it's CGI, it is that good. But it means, unfortunately, the age of innocence is dead. If you see a very interesting looking image on the internet, you cannot tell if it's real or not. When I was young, if I wanted to know whether something was true or not, I looked it up in Encyclopedia Britannica, and that told me whether it's right or not. With the internet, you cannot reliably tell what it is you're looking at. Which is a bit of a shame. It means you have to question everything. So what's the point? Why do so many people believe the moon hoax? Do they really believe that the evidence they're presenting is really scientific evidence? The fact that most of it can be shot down with a little bit of physics, or sometimes not even that, sometimes just common sense is enough to shoot down the evidence that these people present. And thinking about why things might behave differently on the moon sometimes tells us about how things behave on the Earth. And I'm quite pleased to see that some school teachers actually use the evidence of moon hoax as a demonstration of the scientific method. This person is making this claim based on this evidence. Let's look at that evidence and see if it actually does back up their claim. A wonderful use of this collection of evidence and counter-evidence. So next time you see this image, next time you're with somebody that's not at this particular talk or a previous talk of mine, you can point at this and you can say that you know that this is not the image of Aldrin taken by Armstrong on the surface of the moon, and you can tell them why. Thank you for listening.